Welcome to S.S.Bhalaa's World. I am S.S.Bhalaa from class 8. Today, I am going to teach you about rational numbers. This is related to class 7, chapter 9 and class 8, chapter 1 according to NCERT syllabus. Introduction on rational numbers. A rational number is a number which can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. Here, p is numerator and q is denominator. The set of rational numbers is denoted by q. Examples: 3 by 5 minus 4 by 7. Etymology. The words rational number derives from Latin words rationalis numerus, in which rationalis means reasonable and numerus means numbers. Some useful results. 0 is a rational number. Every natural number, integer, and fraction are rational numbers, but a rational number needs to be either a natural number, integer, and fraction. It can be more than one among them. Fractions versus rational numbers. This is a place where you friends may confuse. Let's see to overcome the confusion. Fractions. Fractions are written in the form of a by b, where a and b are whole numbers and b is not equal to 0. All fractional numbers are rational numbers. Example: 3 by 5. Rational numbers. Rational numbers are written in the form of p by q, where p and q are integers and q is not equal to 0. All rational numbers are not fractions. Example: minus 38 by 39. You see friends, here is just one difference between these two, and thus difference between these are very easy. Some useful properties of rational numbers. If p by q, where q is not equal to 0, is a rational number, and m is a non-zero integer, then p into m by q into m and p divided by q divided by m are rational numbers equivalent to p by q. A rational number p by q, where q is not equal to 0, is said to be in its lowest form if p and q have no common factors except form. Have you understood, friends? Addition of rational numbers. If the fractions that are to be added are like fractions, add the numerator keeping the denominator same, and if not so, find the LCM of the denominators, then make the fractions into like fractions and add. The operations of rational numbers are just similar to fractions that you already know. I guess these are easy for you. Let's move on to the next one. Here's the example for you. Add minus 5 by 9 plus 4 by 6. Same as fractions, we have to take the LCM first. The LCM of the denominators is 18. So we have to change into like fractions. See, minus 5 into 2 plus 4 into 3 divided by 18. You see here, it's actually minus 5 by 9 into 2 is how much? It's minus 10 by 18. Then 4 by 6 into 3, how much? 12 by 18. So minus 5 into 2 is 10. 4 into 3 is 12. The denominator is 18. So minus 10 plus 12 divided by 18 is equal to 2 by 18 is equal to 1 by 9 after simplification. Subtraction of rational numbers. If the fractions that are to be subtracted are like fractions, subtract the numerator keeping the denominator same. If not so, find the LCM of the denominators. Then make the fractions into like fractions and subtract. Note 1. If a by b and c by d are two rational numbers, then subtracting c by d from a by b means adding additive inverse of c by d to a by b. That is, a by b minus c by d is equal to a by b plus minus c by d. I hope you all know what is additive inverse. If not, I will say, additive inverse is just changing the sign of the number. For example, if the rational number is 5 by 9, its additive inverse is minus 5 by 9. And if the rational number is minus 6 by 8, the additive inverse of this is 6 by 8. It's just changing the sign. Similarly, another point of noting is that If a by b and minus c by d are two rational numbers, then subtracting minus c by d from a by b means adding additive inverse of minus c by d to a by b. That is, a by b minus c by d is equal to a by b plus c by d. Why a by b minus c by d? Actually, minus into minus is what? Minus into minus is what? Plus. So that only it's there. This is also where your friends get confused. Here is an example. Subtract minus 4 by 5 from 8 by 6. 8 by 6 minus 4 by 5 is equal to 8 by 6 plus 4 by 5. Minus into minus is plus, so that only like this. LCM is 30. 8 into 5 plus 4 into 6 by 30. It's just because LCM is 30 and we have to convert into like fractions. 8 by 6 into 5 is 40 by 30. And 4 by 5 into 6 is equal to 24 by 30. So 8 into 5 is 40, 4 into 6 is 24, and the denominator is 30. So 64 by 30 is equal to 32 by 30 is equal to 32 by 15 is equal to 2 by 15 after converting into mixed fraction and also after simplification. Another example for you. What should be added to minus 3 by 4 to get 8 by 9? Here minus 3 by 4 plus x is equal to 8 by 9. 8 by 9 minus 3 by 4 is equal to 8 by 9 plus 3 by 4 is equal to x. LCM is equal to 36. 8 into 4 plus 3 into 9 by 36 is equal to 59 by 36 is equal to 123 by 36 after simplifications and conversion into mixed fraction. Have you understood, friends? Multiplication of rational numbers. If a by b and c by d are rational numbers, then a by b into c by d is equal to ac by bd. Example, 3 by 5 into 4 by 7. Here 3 into 4 by 5 into 7 is equal to 12 by 35. It's very easy. Reciprocal of a non-zero rational number. For every non-zero rational number a by b, there exists a rational number b by a. This is called as reciprocal. For example, take a number 5 by 7. Its rational number is 7 by 5. Take minus 9 by 7. Its reciprocal is 7 by minus 9, or you can write as minus 7 by 9 also. Reciprocal of 1 is 1 and reciprocal of minus 1 is minus 1. These are the only rational numbers which have their own reciprocals. 0 has no reciprocal. Division of rational numbers. If a by b and c by d are two rational numbers such that c by d is not equal to 0, then a by b divided by c by d is equal to a by b into d by c is equal to ad by bc. We had learned in multiplication as ac by bd, right? Here it's ad by bc. It's just because in division, c by d changes into d by c. The second fraction changes into reciprocal. Now, division by 0 is undefined. Here is an example. Minus 4 by 5 divided by 6 by 7. 6 by 7 changes into 7 by 6. And 7 by 6 is just a reciprocal. Minus 4 into 7 by 5 into 6. Minus 4 into 7 is how much? It's minus 28. 5 into 6 is how much? It's 30. So after simplification, we get the answer minus 14 by 15. Conversion comes simplification. Example, 1.4 squared into 1.5. Before that, convert into rational number. So the converted expression is 196 by 100 into 3 by 2. 1.4 squared is equal to 1.4 into 1.4. That's equal to 1.96. 1.96 is also being written as 196 divided by 100. 1.5 is equal to 3 by 2. Note that for the squares from 1 to 20, refer the first video of this channel, squares from 1 to 20 with shortcuts, and another continuous video, squares from 21 to 99 with shortcuts. You can refer these videos for this. Related to our topic, After conversion, we should do multiplication. 196 by 100 into 3 by 2. Then 196 into 3 by 100 into 2. 196 into 3 is how much? It's 188. 100 into 2 is how much? It's 200. After simplification, we get 294 by 100. Then further simplification, we get 147 by 50. Here I will divide it by 2 and then again by 2. You can also simplify by dividing by 4 directly. So the answer is 147 by 50. You may think this sum is very hard, but when we come into this test, I hope you guessed this is easy, right? Conclusion. Rational numbers versus irrational numbers. This is the point where you need to get an additional knowledge. Rational numbers. Numbers that can be expressed in p by q form are termed as rational number. Rational number includes numbers which are finite or recurring in nature. Example, 3.6767. Irrational numbers. Numbers that can be expressed in p by q form are termed as irrational number. This consists of numbers which are non-terminating and non-repeating in nature. Example, pi, which is approximately 3.1415. To know the pi value up to 50 decimal places, you can refer the video pi value with 50 decimal places in this channel itself. If the denominator is 0, what is the number called as? This is the place where you're eager to know. Let's see, friends. If the denominator is 0, as a by 0, the value is undefined, as a by 0 is equal to a divided by 0. Example, 4 by 0, 30 by 0. This is the same for 0 and 0. Hope you understood this complete chapter. Please like, share, and comment this video. For more upcoming educational videos, please subscribe this channel. In the upcoming videos, we shall see the solutions for exercise 1.1 and other exercises also. So stay tuned. Thanks for watching. Bye bye.